Thank you. My name's Ben Riggle. I am the VP of Sales at Veraset. So it was great to see Clear Channel Ahead because I think it was a really good example of how mobile location data can be combined with other data sets and create some really good business impact. But what Veraset does is we actually provide access to that mobile location data, and we do that in safe and easy methodologies. So some of our clients are here today. Some of our clients are using this data for things like where should we put our next store, where should we make our next critical infrastructure investment, what share of foot traffic do we have as well. And we're really excited to have Paul with us here today. Paul is one of our clients with Sheetz. If you've ever driven through Pennsylvania and into the Midwest, you may have stopped at a Sheetz. Great hot dogs, great gas stations, and of course clean bathrooms, which is the most important part of traveling that way. Paul's going to walk us through how they actually use Veraset movement and visits data to make better decisions internally from everywhere from where should we put our next convenience store to how can we better optimize revenue mix within the stores as well. So thanks, Paul, for joining us.
Okay, so just a quick poll. Who's familiar with Sheetz? That's more than I thought. Great. So this really goes through some challenges we have by looking at Veraset's movement data, but also a solution. This kind of goes into some code. So you guys that like some SQL, I'll show you some. So we'll get right at it. So we'll go through what is a Sheetz, and then enhancing visit attribution using only SQL, and then some future work and areas for opportunity. So what else? What's Sheetz? So we're all about providing some kick-ass convenience while bringing more than just a convenience store. We're in about 6 states. We have 650 stores, and we're growing. So here's our challenge. So we have Veraset movement. So this is the raw human mobility data. As you can see, it has a timestamp, it has a device ID, it has a geohash, it has lat long, and then we have polygons. So this is one of our stores, one of our flagship stores in central Pennsylvania. So we want to find how many of these points or how many of these raw human mobility data fall within that polygon. So the other thing we really wanted to find out was how long do they stay as well. So this is, finding a point in polygon is a relatively easy task. But just trying to figure out like how long do they stay is really it's a challenge, but with Databricks it makes it a little bit easier. So with the H3 functions, we can do this in only SQL and not have to bring in any of these external libraries. So this sort of goes through it. So the movement data, it's really non-aggregated human mobility data. We get their feed is about 125 billion rows per month. It contains timestamp, device ID, lat long, and then some other things. So to add further color, we added a H3 index, and it's available in the Databricks runtime, 11.2 and higher. So that's just the function that goes into it, and we took it at the H3 level 15. So for those that are familiar with H3 or not familiar with H3, it goes from 0 to 15. So 15 is the most granular that it can possibly get. So for most devices, we can estimate dwell time since they have more than one ping on a given day. So we had to eliminate all the ones that had one ping, but for most devices that fall within a day, that we're able to calculate a dwell time, and then we just use this using a lead window function. So there's the piece of SQL at the bottom. Next, we have to parse the polygons to H3. So this is all the polygons that we have are in well-known text format. So we have to get their H3 equivalents. So all we have to do is write an explode. There's a handy function called polyfill, and then it provides all the H3 functions within that fall within H3 indexes that fall within that polygon. So here's the code. So since these are both now tables in SQL, we can just do a simple join. I know this doesn't look so simple, but I'll walk through it a little bit. So essentially what we're doing is we're taking the Veraset movement data. We're creating a temporary table just to make things a little bit faster. We're joining that to all the H3 indexes from the polygons. And then what we're doing is just having a halving function at the bottom where we're calculating dwell time. And then for that dwell time, it's less than 2 hours. So basically, the pings need to be less than 2 hours apart. And then we're just rolling that up to get some summary statistics. So at the top there, you can see some extract the hour from the timestamp. You take the minimum timestamp of whenever it started to, whenever that device first appeared on that lot. And then you sort of take the floor of the dwell time, since it's in seconds, divided by 60, and then that gives you the minutes. So before we inserted this into a table, we just filtered out dwell times that are less than a minute. So as you can see, from those 125 billion points, we were able to pick up 5 million records of a dwell time of a minute or less, 4 million with a dwell time of 2 minutes, and then 2.8 million with a dwell time of 3 minutes. So this whole process before the H3 index took about 2 hours to run. And then now with only these joins and running some Z order on these Databricks tables, it only takes about 7 minutes to run. So that was a huge process increase, especially dealing with the volume that we were dealing with. So some of the next steps, we're continuing to analyze the use cases for this data and how it applies to our business. And then we're trying to explore some more functionality with H3 and how it improves some processes. So finished up pretty quickly. Went through that. So if there's any questions, I can answer them.